Good morning still, everybody, and thank you so much for joining us here today. I'd just like to apologize, first of all, if I'm a little bit shaky on my voice. Andrea was a close friend, and for us, it's particularly difficult to lose him. So I'll try and lift it up a little bit if I can now, smile a little bit, and we try to go on, okay? So today, I'd like to talk a little bit about the introduction of Giga casting and how this has affected the body and white industry for the automotive sector. If we look at where we are today, you can see here an example of 6,000 and 9,000 ton machines side by side. This is particularly poignant because this year IDRA is celebrating 80 years of its foundation in 1946. And for me, as also a very old member of the team and member of die casting, it's incredible to see the journey that we've made. In 1946, we were dealing with a manual machine, making castings by hand, pouring by hand, but zero hydraulic problems, zero electrical problems. And we moved from there in a matter of 80 years to here at the Giga press. But I think one of the really notable things here, and it makes me laugh as somebody that's been involved in the marketing within the company for some time, is that even during the 1960s and the 1970s, look, we were hinting at the future, putting a car between the platens and stamping it in one piece. So let's talk a little bit about what is an underbody cell. I think there's a lot of discussions about people trying to understand what it is that we want to try and do. So essentially, the difference between a standard die casting machine that many of you here in the audience are used to and a Giga casting cell is really about the requirement of support that we have for the die. We have very fast solidification times. And of course, we need to be able to fill the die in a short time. Now, for us within IDRA, this was great because we were able to learn and cut our teeth about this kind of process, working in magnesium during the early 2000s. And we really had the opportunity to grow and be part of the body and white growth. And when we decided that we were going to do this, I think there were many, many people in the industry that were skeptical about whether this was going to work and whether we'd be able to actually produce the castings. But in 2020, the first castings were made in California, and the rest, they say, is history. So we're very happy to be together in this. And we've actually got a worldwide distribution of machines, not only for GigaPress, but also for the medium normal sector. I think all of us were particularly worried that what's going to happen with electrification, how will our jobs be affected, how will we go forwards? Well, I think one thing that's clear, guys, that we've seen is through political policies, through global impact, we see that there is still a very strong trade for aluminium. The rumor that the internal combustion engine is dead has turned out not to be true, right? We're all here. So essentially, let's talk about some numbers. Clearly, IDRA is part of a larger group, the LK group. And if we look just at what IDRA is doing, we have been able to achieve somewhere around 30 machines in full production. We've produced somewhere around 3 million vehicles now that are driving on the road. And then together as a group, we've now delivered over 85 cells into the marketplace for changing the way that we do automotive production. Now, none of this is possible without a team, and I'm very happy to talk just for a moment about our partners in the FSA. So each one of us within the Foundry Star Alliance has a role that has allowed us to move forward so quickly. Let's be honest, before 2020, from 2018 until 2020, this was really just thinking about what we wanted to do, how we were going to move this forwards. But we were able, together with our team, Co-Stamp, as we saw before, for dyes, Fonderex on vacuum, IECI for thermal regulation, Volin on spraying, Stotec for furnace technology, air purification, and automation for Iruña. Together, we were able to put together a system that works and produces. In my opinion, there's nothing worth doing unless we're actually going to contribute. So this team together has been able to make this a realization. So let's talk a little bit about where we were, right? And for us, this journey really started in 2016, when we started working in the structural casting sector. We were looking at, okay, what's going to happen? How are we going to go forwards? How do we prepare for the future? Which, by the way, is a little bit what we're doing right now, no? We're thinking, how the heck do we go from 2026 to 2030, right? We're trying to prepare for the future. And what we did is we came up with this idea that in order to be efficient, let's do what we always do in die casting. Let's do multiple cavities. But the castings are bigger now, right? So now we're starting to struggle a little bit on the machines. And I remember very clearly at that time, we were working with tooling, with having hydraulic clamps in the tool. We used to call it tonnage assist, to try and hold the metal while we were casting. So we started in 2018 to look at the feasibility of what can we do. And one of the questions we asked ourselves, guys, was we said, what is the best way to move forwards as a die caster? One of the factors that was very clear for us was we came from an environment with engine blocks, transmission cases, sumps, bed plates, etc. And it was one casting for each car. And of course, it was more than one motor for each vehicle, right? So there could be motor variants, but essentially one casting. Then we moved to structural casting, and all of a sudden, there's a left hand and there's a right hand. If then we start to look at the most famous example of structural castings, which was the suspension tower, okay? There are 4 suspension towers in every car. So we came up with this idea of thinking, well, how about we try to make everything that we need in one shot? So one shot, one vehicle. So maybe we need 4 impression die with shock towers inside. And this led us towards a feasibility study for actually implementing a new idea. In 2019, we were approached by an OEM out of California that wanted to embrace this idea and wanted to go forwards. But they didn't want to follow our idea of multiple impression. They actually wanted to start casting the underbody of the vehicle in one piece. And so in 2019, we got the green light, and then we decided to move forwards to 2020, right at the beginning of COVID. It's fantastic. But this kept us super busy, and we tried to move forwards. And in August 2020, we made the first casting. Subsequently to this single OEM, we have delivered over 25 machines, producing more than 3 million vehicles in the time since, in the last 5 years. So one of the things that I want to say clearly, as you might notice, I'm no spring chicken. I've been in the die casting industry now 40 years. And hey, I'm starting to get a little bit old. I'm starting to get a little bit more tired. It's really important now, ladies and gentlemen, that we bring forward the young guys, that we try to enable them, empower them into the world of die casting. And I think one of the things that's really helped us a little bit is that this whole electrification, the work that we've done with Tesla and with other OEMs, is maybe, I like to say, making die casting a little bit sexy for once. You know, I've been in the trade very long time, and for me, if you start talking about die casting to people, they fall asleep, right? So I really want to try and lift the profile of what we're doing. So our work with the universities in Europe and trying to bring the young people forwards is super important, I believe, for the future of die casting. And if we don't grow, then we won't survive. So let's talk a little bit about what's happening. So clearly, there are many political, geopolitical factors taking place right now. And without making comments about Venezuela, etc., certainly the use of petrol-based, oil-based products is not finished at this moment in time. However, what we can say is that the European growth in EV has been strong. Clearly, the main drivers for this are development of infrastructure for charging. All of us maybe have some difficulties to find a charging spot for our electric vehicles, but making sure that the battery technology actually gives us also the distance that we require. You know, generically speaking, if we're going to do a plug-in hybrid, we need to have 80, 100 kilometers of independence on battery to be efficient. And of course, the new standard for batteries is now 700 kilometers, right? So we're moving more towards an efficient 1,000 kilometers that we always used to do. Policy making and policymakers, whether it's the European government or whether it's a North American government, this is one of the main driving factors. And I remember very clearly as an Englishman working on automotive for pretty much all my life, you know, there was one time when they said to us, no, you don't want to be driving petrol, you're poking a hole in the ozone layer. So then we all switched to diesel, right? And then they said, no, you don't want diesel, now you want electric. So we're really being driven by the policymakers on this. I think if we look currently in Europe, there has been a real stalemate situation. So we know that the technology works. This is no longer a discussion. There are millions of vehicles out on the road using underbody castings now, so it works. But the point is that there's also been a lot of difficulty in this economic times to actually invest fairly large sums of capital into a situation that's not guaranteed by the OEMs. So this means that the growth in this area is primarily led by the OEMs and not the Tier 1 companies. So more than 80% of the investors in the world today are the OEM. So let's talk a little bit about what is the market. The growth rate was very rapid and strong in China and has been driven by affordable vehicles, right? At the end of the day, the Chinese challenge has been to embrace the technology, to embrace the production technology, and I think their statement was that they want to be #1 electric car manufacturer in the world, and I think that they're striving in that way very clearly. I think the expansion of China abroad is a real thing, right? We're starting to see it here in Europe, and if I could just touch on one thing personally, you know, I come from Birmingham in England, and now I'm driving behind a car with an MG badge on it, but it's not the MG that I remember, okay? And I think one of the things that we have to understand is that this is a real thing. If we in Europe, in the automotive business, don't step up, then our place will be filled by somebody else, okay? If we leave a vacuum, that vacuum will be filled by a different supplier. So I think that the EV market continues to be led out of Asia, particularly out of China. But I'm also super enthusiastic that we don't lose sight of this, that we don't just hold up our hands. The European manufacturing has an immense history, has a fantastic pedigree, and I believe that there is still a very strong place for us within that. And as a company, we're committed also to supporting this. Material uses. Well, look, the process is becoming more relevant. We're working on alloys. We now have recycled alloys. We're overcoming a little bit of the problem of primary alloys. But at the same time, guys, what's the problem? We don't have any scrap anymore. We've been selling the scrap outside of Europe. So now we need to try and recover some of that scrap, bring it back so that we can do recycled alloys. And some of those people are here today. So where are we going with magnesium, right? How many of you here were, like me, involved in the magnesium trend, what was it, 20 plus years ago now, where we all thought that magnesium was going to be a huge driver going forwards, and it stopped. Now there seems to be a resurgence of this, and I think that with the new technologies that we have, with the Giga casting, with the thixotropic casting, yeah, we can do something different, and we can go at it again, and hopefully try not to burn down too many factories while we do it, okay? So the main investors, I repeat, are currently OEM and some tier ones. Let's talk about this. The Giga casting was a disruptive innovation. And this innovation was first utilized in the US, not in Europe, but in the US. However, being supported very strongly by European manufacturing. The growth rate in EV sales grew pretty strongly, I think, until 2024. And then there was a small political change in the atmosphere, and this kind of flattened things off a little bit on the EV sales. I think the regulation rollbacks mean that we're going to see a continued use. Recently, one of the things that I heard was that there is a resurgence of the V8 engine and moving forwards in this area. Investment will continue to be strong in the US, but also the Japanese are not to underestimate. They're moving forwards. So, the key advantages. We need to create sustainability. We need to improve our key chain logistics. We need to be able to move these castings around easily. But more than anything else, we have to continue to drive and change opinion, shifting the paradigm that we have more to offer than just sumps and engine blocks, but we also have structural underbody. There are many different things that we can do, guys. So if I can jump now just quickly to the point that I would like to emphasize. One of the other things that we can do in Europe is to look on how we retask and reutilize our existing equipment. And part of what IDRA is trying to do is to enable our customers to create a resized deployment. Meaning, if you want to go gigapress, you want to go 9,000 ton, you want to go 20,000 ton, the capital investment and the real estate is quite hard. So why not create also an infrastructure based around empowering the machines that we already have, the tonnage that we already have. And we affectionately like to call this the mini gigapress series, building a bespoke custom machine that will fit inside the space that you have available. So, last point, supercar seminar that we made, we need to also look on how we're going to utilize the different materials and join them together. Joining has been a great thing for us. And so we are working together with other companies to create solutions that allow us to join composites, steels, plastics, and aluminium together in one vehicle structure. And here you can see an example where we're using a riveting system. And this riveting system allows us to join the various materials together without welding specifically that material. So what I'd like to do now is to, it seems that my time is gone. Maybe I'm a little bit too enthusiastic going on about these things. Okay, yeah. So I'd just like to say that part of what we're doing is also to be involved with our customers in the passion for cars, the passion for motorsport. So you're all very welcome to come to our stand and have a look. We have the car that was competing in the 2025 Indy 500, and we were very fortunate to take an Italian team into America to the Indy 500 and take pole position. So I think at that point we'll leave it, we'll hand back to the moderator, and thank you so much. And please everybody give a thought for Andreas. Thank you so much.
Sorry, John, but we see each other in a bit for our panel discussion.
Yes.
So thank you very much for the moment.